Hello everyone. So my name is Wishnu Prasetya and I'm from Utrech University. It doesn't say there, but that's where I'm from. So I'm here to present some of the things that we do in this Erasmus Plus project called Impress. And this is the title, adding a little bit fun in teaching formal specification. Right. So let's start the presentation here with this statement. Software engineers should really write formal specifications. So at least that's what I believe. So I know that in practice people do not do that. My students do not do that. And well, I'm trying to teach them, to encourage them to do this, but it's also not that easy. Now, some of the things that make this is not easy is because, well, there is also some belief, you can say old belief, that is circulating in a community of programmers, engineers, even computer scientists, that writing formal specifications require sophisticated mathematics. Well, it used to be in my days, at least. Yeah. So you would need to produce a document like this with very obscure notation. You need to be able to write a little bit of LaTeX, and this is just pretty hard. I mean, not every programmer has a university degree, and if it is already hard to encourage our own university students to write this, then it's even harder to write professional programmers that do not have university training. But well, this is really in the older days, maybe where I start at my university, but you probably also start around that time. But I don't think that's still the case. So many programming languages nowadays, they are expressive, powerful enough that will allow you to write specifications, at least to some degree. Maybe not all type of specifications, but languages like Java or C#, they do come with things like lambda expressions, which you can write nameless functions. So essentially, you can write things like the quantifiers. You can write pre and post condition in this code fragment you can see here. This is where I call a certain method, so that will be my real program. And then there I can express the usual pre-conditions and post-conditions, and this is being expressed here natively in Java. Things like quantifiers used to be a little bit problematic, and of course you can just write everything in Java. It's after all Turing complete, but it's not going to look very nice. And you do need quantifiers once you want to talk about more complex data structure. I mean, if you just want to talk about integers, then you do not need those, not really. But as soon as we need arrays or collections, then typically you would need to have quantifiers. But fortunately, now you can express those. Yeah, so the previous argument does not hold anymore. But still, so let's go to the next slide. Still, it's not easy to teach students to write formal specifications. This is a bit strange because you just saw that you can write it in Java, and all those students are good programmers, better than myself. They have background in logics, so you do have the ingredients, but somehow writing formal specification is just well, a little bit more difficult, at least without some training, right? So this is the example of answers that you can get from students, from my students at least, when I ask, write a specification for a method like has common member given two arrays of integers, then this method is supposed to return a Boolean. It checks whether there's an intersection, whether the intersection of the two arrays here is not empty. You can get answers like this. Here, for example, where it's not even syntactically correct, or it has something that is, pretty weird. Yeah, so here it says some expression, and then the return value has to be either true or false. I mean, of course they are either true or false. Yeah, so with all this effort, they end up writing something that is actually does not meaning anything. Yeah, so they are actually in the right direction, because this is a fragment that they try to say, oh, there exists two elements in the arrays A and B in which they are equal. So they are really trying to say that the intersection is not empty, but it does require a bit more effort to actually express that in the right way. Yeah? The thing is, when we try to make them do exercises like this, because without doing this exercise, then they will left untrained, and then when they go into the programs or programming, then they will always end up making this kind of mistakes. Thing is that what has been pointed out by previous speakers is that trying to explain this in the class, trying to make them doing exercises is like this. Yeah? So we need to have, well, not we need, but let's say that we are here to try to come up with some innovative way to at least mitigate this. That can feel, they can feel a little bit more motivated. And games have been an idea that has been proposed for quite some time. You have seen Code Defender. This is another game. This is called a programming contest game from Microsoft. It's called PEX for C#. Well, what we want now is not really a game to write a test like Code Defender or a game to write a program, but we want to have a different game that can teach students to write pre and the post condition. Now, what we also decide to do in the project is we would like to experiment with a different approach. So you can see here in the screenshot, this is PEX. It's very business-like. So it's more right to the point. It's quite technical look. So because the subject is also technical, it's about writing program. So you get an interface that is very much in the sphere of writing program. So we want to take a different approach that by making a position that if you want to try to eliminate the boredom being boring here, so let's introduce some fun. And if you want to have some fun, then you really need to make space for this fun here. So we decided to really introduce a game. So this is a game. It's basically a tower defense game. So you might wonder why tower defense game. There are different genres of the games, but there are also considerations to take here. If you introduce an adventure game, then it may take days to complete. So maybe that's not a very good idea. So we need games that can be played short, and we need a game that people is quite familiar with the concept, because this is definitely ripping students away from the context. It's unlike PEX, where you are still set up in the same environment, and this will take students away from the familiar context. So we need something that is somehow they can associate themselves with, and tower defense is known to be quite popular. Well, I wouldn't claim that everyone knows that, but a lot of students know that. So we decide that's the game here. The idea here is Here you have a short description of informal specification of the program that is supposed to be built, supposed to be specified. Let's call it a min here, a program min taking two parameters, for example, x and y. And then you have a short description, a textual description. Something like, well, given two non-negative integers, then this program is supposed to return the smallest of the two, for example. And then the task is for them to formalize the pre and the post condition of this program as formulas, though not directly as those. So everything needs to be cast in terms of the game mechanic here. Now you see a lot of circles here. The red one here is something, well, it's a CPU. The entire game this is basically a print, a plate that you will see in the computer. Somewhere on that plate here, there must be the CPU. The CPU represents the program being specified here. And the blue lines here, there are two. One coming to the CPU, that represent the input to the program, and one coming out from the CPU that represents the output of the program. And what you see here that later on will traverse the input and the output, you can see data packages. You see the blue data packages, so those are the good data packages, representing data that is good, that's satisfying the intended precondition. Or if they are here at the output side, those will be correct outputs that are produced by the program that satisfy its post condition. Now, we also deliberately make the feel or the undertone of the game here a bit underground. And then we tell the student, you know, the theme here is that there are hackers that are trying to sabotage your program here, and they are injecting corrupted data packages. So those are the reds that you see here. So obviously, the goal of the game here is to catch the red bubbles, the red data packages. And you need to do that, then you need a scanner here. If the scanner is programmed correctly, then all the red data packages will be marked. And then to introduce the fun element to the game, because I said this is a tower defense game, then here you see another pane here where you can buy towers. You can put it along the inputs and the output lines here, and then they will shoot the packages that have been marked. Yes. So the play element here, so the towers are actually optional. If a smart student managed to figure out what the pre and the post condition first time, then that's also fine. You don't actually need this. For students that like this as something to play with, then they can actually play with the towers. And putting these towers actually also, well, it has a supportive role in the game, in the sense that you do not put anything and you do not get it right the first time, then your life will lose faster than if you didn't, than if you did put some towers into the game. All right. So now let's see, another concept of the game is the idea of constructionism. All right. So what I told you about scanners. So this is a scanner, and we are supposed to build this formula, the pre and the post conditions, so the formal specifications. So what we take a position in this game here is that, well, you know, you are not allowed to just type in the pre and the post condition, but we slow down your process. We actually require you to build, well, a complete circuit representing the formula. So it's basically, if you know a bit about how expression is represented, this is the parse tree representing the expression representing the formula. So they need to build this using different components. You can see here there are A and I, those are variables. A in this case probably representing an array. I is also, well, a variable representing some index. This is a box representing an array expression, the ith index of an array A. And there is, well, you cannot see it very clearly here, but this is a for all quantifier. You can quantify over an array and indices, and this is an expression being quantified, and so on and so forth. Yeah? Now, the idea of taking this workaround, well, not workaround, but you are not directly typing the formula, is that this refers to the idea of constructionist way of teaching. That says that, you know, people learn better if they can operationalize what they learn. They do not learn just by putting things directly in the mind, but they construct the knowledge by associating every fragment with something that they know, and they construct it in their mind. And that's something that we sort of try and are enforced to do here to the students. They need to actually drag the block and then link it explicitly using the construction box here. And in that way, they explicitly construct the relation in their mind in slower pace. Now, there's a good thing and a bad thing here. If you are a good student, then this is going to be pretty annoying. But if you are on the slow side, then I think this is nice to have, because this can basically helpful to strengthen the acquisition of knowledge. All right. In terms of feedback, there are two kinds of feedbacks that the game provides. The first one is just the visual one. So remember that you have this, the blue data packages. Those are the good inputs or outputs. And you have the red ones. Those are injected by a hacker. And if you have a precondition there, you have a scanner, a formula in the scanner, then basically inputs or outputs satisfying the formula will be marked, as you can see in the top left example there. So that's an example of bad data being marked by a scanner. Now, there are two things that can happen. If the scanner is overspecified, too strong, then it will actually mark data that is also good. That's also not good, right? Because then you prevent something that is actually good to reach the CPU, or the other way around, from leaving from the CPU. If the scanners, the formulas, are underspecified, then you will end up not marking some of the red data packages. So that's also not good. So just by looking at the color and the marking, students can get a feel whether the specification that they build are too strong or too weak. They also get more textual feedback, so like this here. So this is basically a counter example. If the scanner is not the same, is not equivalent as the one that is provided by the teacher as the model solution, then it will provide a counter example, and then it will try to formulate it in the way that encourage students to think. So for example, what if the x and the y is both 0, but the return value of your program turns out to be -1, for example? So then he thinks that, yeah, that's not really what the intention of the program here, because it's supposed to return the smallest of the two, but instead it returns something completely different. So that encourage him or her to think, and then repair the corresponding scanner. So there is also analytics backend, thanks to the team from UCM, Ivan. So we hook in an analytics And well, this is very nice because then well, before you know that students play the game in the classroom, but this gives you a global overview of what they are doing. So let me point some examples. So here, what you see here is the recording of the formulas that they try to build. Not just the final one, but as well, the intermediate ones. So that you can see, for example, oh, they are typing something like this. Is this making sense? Are they having a problem there? So then you can see, if you see more of the students typing in something that is just nonsense, that you know that your class have a problem, then maybe you need to intervene. So this is example of feedback that you can get in more details as a teacher, but you can also get a more strategical feedback that is represented by the graph that you see of there. So here, for example, is the life, the amount of life that is remaining during the game. You can see that this is supposed to be okay, but if you see that many students start to have their life dropping very fast, then you see that the game is perhaps not very well balanced. It's too difficult. They are losing too quickly. This is the graph of towers that they build. This can be an indication in how much fun they have. If nobody is building tower, then maybe the game is not the right, well, the right tool for your class because nobody is trying to do to have some fun. If a lot of students are building many towers, then maybe the game is well, they are having too much fun. So maybe you also need to intervene there. All right. Okay. So the experience so far. So we run this in 2 incarnations of my course at Utrech University. It's called Software Testing and Verification course. Well, the amount of students is about 80, so that's a bit smaller than the class in Passau, I think. The first time is just an alpha testing of the game, so it doesn't really represent much. We ask a group of students to try the game. The second year, we actually try to integrate this into the teaching. It's first time for us, so we were a little bit more careful. And also, I think this is a different kind of game, whereas in software engineering you see a number of gamification already, but those tend to be the more serious kind of games. And for those, you can look in the literature to see experience from people. And for this genre of education game, there is very little. So we are not very sure how to integrate that. So we took a bit more careful approach by not making the doing the game here as a mandatory element, so it's an optional element. So in the end, from 80, so hold on. So we deploy 5 assignments with the game here in the increasing complexity. But I think it's also useful to point out that the class is a fast-moving class. It's a 7.5 EC course, not only on software testing, but on software testing and verification. So they get half about software testing, and the other half is about logic. So you get OR logic, and then they need to really prove the correctness of a program using programming logic. They get project, they get homework, and they also get this as an optional element because writing formal specification is one of the learning goal. Well, it is hard to balance. Students are already overcrowded with assignment and with project and exams, so it's not that easy. So in the end, there were about 19 students that decided to try the game, and I think that the overall feel is that they generally appreciate the concept. And they actually also learn something from that, because playing the game is quite revealing. You get the feedback immediately if you do not do it right, and then it's quite revealing for them that, all right, so obviously writing specification for even something simple and small is harder than they thought. And otherwise, if they submit a homework, then they do not get a feedback right away, that it only several days or even the next week they get a feedback. And even then the feedback is only in terms of this is good or this is not good, right? And then the game is able to be, well, it is more interactive, and it can give them more incremental feedback. So they learn. What they definitely do not like is how we try to integrate this, because, well, like I said, they already have a lot of activity. So I guess that the hard lesson that we learn is that, you know, integrating a game into a class is really something that is requires some planning and some thought. It's not just because, oh, it's a game, then let's do that because it's fun. It's more than that. It's basically require you, it may require you to change the way that the course is given, because then it's supposed to introduce some fun. Then we need to make time to let the students have that fun. If that time is not given, then it's not going to work. And making time for them to have some fun means that we may have to sacrifice some of the learning goals as well at some other places. So it's a bit difficult to a consideration to make. Though yesterday I had an opportunity to try this at UCM here with a group of 10 students. And there the setup is different. Well, student is not being stressed by having to do this as part of a course, so there is not really a mandatory goal, and it's a dedicated 1 hour when you can take your time, you can explain to the student what the learning goal of the game, and then you can help them, and they have the time to actually focus on doing the game. And it seems to work much better. They seem to appreciate it, if I'm not mistaken. And I think that at least when I asked to some of them, then they seem to acknowledge that they do learn something from this. Going back to the pilot that we did, whether playing the game actually improve the academic result, I think that the same statement as what you guys observe. Maybe there is some correlation. In our case, there are only 19 students, so it's not very statistical significant. And from those, you can say that there is no correlation between what they do and the final mark. But I guess that it depends on how do you want to deploy that. I mean, here, if we try to engage students a bit more to make them more enthusiastic, and then on the premise that if they are enthusiastic, then they learn better, then this might work, although integration is something that we need to think about. Another thing that we also learned during this experiment with Impress is that this game as a proof of concept is fine, but it is, you know, the engineering is really not trivial. You have maintenance to worry about. If there are issues, then you need to fix those. And as you can see, well, the graphics might be, well, you might be impressed, but there are definitely commercial games out there that look much smoother than this one. Yeah. And I guess as students nowadays is a bit sensitive to how things look like. So there are a lot of, I think, interesting concepts in the idea here. Really the idea of having gamifications that put more emphasis in the fun, trying to create time to let students have those fun. I think this is something that is worth trying. There are this kind of things that is, well, really not trivial. This kind of things are difficult for researchers or for TAs or for team of students to establish or to maintain. So I guess in longer run, if we are really interested in, really want to have this good gamification being integrated into a game, at least for this genre of game, then I would recommend to work together with professionals in this case. Yeah, balancing is also something that is very difficult. Okay, so let's go to the future work. Yeah, we would like to continue our study, so we still have 1 year or almost, well, 1 year left in the project, and there is one more run for the course, the same course, software testing and verification, so we can do one final study for the idea here, for this kind of game, and something further in the future, so maybe we, can explore all the forms of the combinations of the fun way of doing gamification and in combination with constructionism. Maybe it doesn't have to be in the form of tower defense game, maybe it's something that is more artistic. So this is the painting of Mondrian. You can see there are, it's consisting of blocks. So maybe we can use something like this to, to do the gamification of, UML design, so learning how to model with UML. Okay, that will be all from me. Thank you. So if you have questions, then I'm here. Yes, please.
So you said that you could that you made the experience that people have more fun when they're in a relaxed situation or in a relaxed session where they are not graded.
No, it was the expression here when I run a demo of this in a demo session for 1 hour with UCM University.
So do you have dedicated time in your course to just students learning the game? Or is it always
no, it's intertwined. So I said that this is optional. And then I sort of encourage them to do those, and then you would have half of the classes doing something else, and then half of the class that is, well, trying to do the game, and then I'm there to help them or explain things about the game. Yeah. So that's not ideal. Yeah. Because then when you see your neighbor, oh, they are doing a project, and then you sort of have a feel, okay, maybe I should switch to the project as well because I'm a bit behind in the project, so that, yeah. Yeah.
more questions?
Okay, thank you.